Hello, everyone, and a very good evening. Dear authors, session chairs, and invited guests, welcome to Technical Session 11D. Myself, Samruddhi Mughal, and I will be the moderator for this session. On behalf of Global Knowledge Research Foundation and Geoscholastic, it is my great pleasure to welcome you to the 10th World It is my great pleasure to welcome you to the 10th World Conference on Information Communication Systems, Software Security and Sustainability, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was successfully held yesterday in London, UK, and the virtual event is being conducted through Zoom from 29 to 30 July 2026. I hope you all enjoyed today's informative, insightful, and interactive technical session. In this session, we have six paper presentation. Each presenter will be allotted 12 minutes for the presentation, followed by 3 minutes for the question and answer session. I will give a gentle reminder when 10 minutes have elapsed to help you manage your time. I would also like to request all participants to kindly stay connected with us until the closing remarks for the session. If you have any queries or require any assistance during the session, please feel free to write to me in the chat box. Before we begin the presentation, I would like to introduce you to the distinguished session chair for this technical session. Today we have Dr. Deepak Mane, sir. Dr. Deepak T. Mane is a professor and deputy director, IQAC, Vishwakarma University, Pune, India. With 20 years of teaching experience, he has authored books on machine learning, fundamentals of programming languages, and principles of programming languages. His research primarily focuses on machine learning, deep learning, supervised clustering, and pattern classification. I may now request so to please kindly share a few words and offer their valuable insight and guide the presenters before we begin today's technical session.
Okay, so good morning or good afternoon, good evening to all the participants, and yeah, best wishes for your presentations. And I am waiting for listening your research about in different areas. Yeah, please, ma'am.
Thank you so much, sir. So let us begin with our today's presentation. Our first presenter is Marcus Paulo Generoni Francisco. Paper title is A Comparative Evaluation of LLMs for Threat Modeling in Software Security Assessment. You may start your presentation.
Okay. So, first of all, thank you everyone for joining today. I am Marcos Francisco. I'll be responsible for a presentation the result of the comparative evaluation of the LLM for threat modeling and software security assessment. It is stood was part of my master course in professional technology services here in Brazil. And my co-authors here is Carla Lima, Napoleon Gale, and Dr. Joshua. Uh, okay, if what's the problem we want to contribution in this research in this study? That the cyber attacks move so faster and it's more sophisticated every year. In this kind of the threat and risk impact about in the trillion of the dollars per year for companies in the worldwide. Threat modeling it's a relevant threat to avoid this kind of the impact in the production environment and the software in general. In the other side, the attackant, the hackers is more sophisticated, more quick, and more faster. In the other side, we can use the kind of the new technology like in LLM for help the security teams to be more effective, more quickly to identify and result in the neutralization this kind of the vulnerabilities and the threat in the software. This research, it's not to the goal of this research is not to compare to what's the best or LLM, but how each LLM can contribute and for help the security teams. Here we use three different LLM vendors. The first one, OpenAI, the ChatGPT. The second, the Google Gemini, and Manus to compare different approaches, different LLMs. But we take care the standardization, all the prompts, the system to create the same baseline, but we use the same baseline, the same criteria to evaluate this system, but in different LLMs. Okay, the method here, the first step we defined of the target here, we use a real system in production for one more tag. This solution, this software has a sophisticated architecture using uh, Reback control, external APIs, access different databases like Postgres and MySQL, use the external components. It's a little bit complex. With more complex, more the supervise of the attack supervise because we pick this specific software. We set this code, establish the frameworks, the data sets, the prompts that we want to apply, standardization the prompt, sorry, run and apply these prompts directly in the software. Okay, how we can measure here? We define different criteria to measure the effectiveness of each LLM because we need to have a high rigors here to create some criteria for balance this kind of thing. The first one, threat identification. It's to identification the covers of the relevant threat to discover. The second, the technical deep, the root cause, the attack chance, and the real components. D3, the risk classification, use and the correlative, the threat identified in the use the standard frameworks in the market like Stride or Mitri, counter recommendations and real result consistence. The five result consistent, it's more one layer to avoid like hallucinations of the LLM. It's a big problem that we know that when you use this kind of the technology. In the final of these five criteria, we create the FEM, the final effective method to evaluate what's the best approach to LLMs use to cover these points. Okay. Okay, move to results. The dimension one we have here. We have here the Gemini, ChatGPT, and Manus. Here we can identify, for example, what's the evaluation, if the individual evaluation between specific LLMs. Manus has incredible cover in different aspects, especially the one, the two, the four, and the five. Gemini here it's pre-quality more not effectiveness, to be honest, when to use the classification criteria. And Manus cover what the best in the general, the best approach for ever criteria identified. One important and relevant point here is D3. D3, it's about the risk. Ever LLM has the same average outcome, what results here. It's important to observe this kind of the behavior because the risk it's important as well because to classify the risk and impacting directing the production environments or these attack chain, it's relevant. All LLMs have the same weight here and the same results. Okay, what kind of the threats did they catch? Here we create some structures about the star XLR, refresh token, reback and multi-tenant isolation. Gemini failed to identify this kind of the threat for reback bypass and multi-tenant isolation failure. And ChatGPT menus have the same got you covered this all aspect in the general. Total threats identified by LLM. Manus has one expressive amount of the threat identified. ChatGPT it's so close than Manus, and Gemini was so poor about to identify the total threats, just identify five, and the other one, 20 and 26. It's big and the expressly different. What's the severity threats by LLM? Manus have a balance in between the high and critical and the low. Gemini classify the majority threat that in the middle, in the blue, it's the high. Here in Gemini, they identify more medians, high, and the criticals and origin. And Manus has more distribution, a normal distribution between the criteria. Severity distribution by LLMs here. Manus, again, not only identify more threat, but the outperformance of other two models combined the criteria in critical, the high severity vulnerabilities. ChatGPT, it's the second position here in the medium severity threats, and Manus cover direct association with the ability to identify high impact risks here. The severity heat map by LLM, Manus, again,
Sorry to interrupt. Sorry to interrupt.
okay,
It's a gentle reminder that you have only 1 minute left to conclude your meeting.
okay, thank you. Manus have the more critical here, and the final effective metric is here. Manus reach the best position to identify and all criteria and the average criteria. Manus is the best here. The ChatGPT in second, and Gemini in third. Discussion here. LLM can be a relevant support tool for help the security teams. It's more easy and to apply and to identify and classification risks. For the future, we have a recommendation to evaluate more LLM models like the Chinese and the open source to expand the coverage of this kind of the threat modeling. That's it. Thanks so much.
Okay, as per your result, Manus is giving the better performance than ChatGPT. So, why?
Um, I don't have a one single answer for this question because each LLM has these individual training models criteria, but Manus performer out here in using the same structured prompt in the same code base, Manus cover more threats, identify more threats, more risks, and in the high critical risk. I'm not sure, to be honest, because it's one individual criteria, the deep knowledge of the LLMs. It's the idea of this work to clarify more this kind of the criteria.
Okay, and regarding performance evaluation, 5 measurements. So, how you can compare which parameter is giving the good performance or identify the threats in which case? Performance evaluation dimension. You mentioned the 5.
Could you repeat or explain again this question,
Okay,
please?
in your presentation, you
Mhm.
mention the evaluation, performance evaluation measurements. 5.
Okay.
So how you can say which parameter is giving the better performance in which case?
Okay, we inspire our criteria using the ISO 2500 to create this kind of the criteria and the evaluation each one because it's like a how do you say parts or piece of the parts of the quality software and some specific part of the software relate about the security and the software engineer, uh, how do you say, software engineer criteria. We establish this kind of the criteria using the ISO parameters.
Okay, thank you.
Welcome.
Thank you so much, sir. So with that, we'll move on to our next presentation. Our next presenter is Python Nireku Tandong Paul, and the paper title is A Machine Learning Model for the Early Diagnosis of Breast Cancer. You may start your presentation, sir. Paul, sir, are you there? Please switch on your mic.
I try to share my screen.
You can share your screen, sir.
Do you see my screen?
Yes, sir. Your screen is visible.
Eh?
Your screen is visible, sir.
Okay. Okay. If I can start, you to tell me.
Yes, sir. You can start your presentation.
I start?
Yes, sir. Yes, sir. Yes, sir. You can start your presentation.
Okay. Thank you for have giving me the opportunity to present my work. The title is a machine learning model for the early diagnosis of breast cancer. The 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 presentation outline is introduction, tools, and methods, experiment, result, and conclusion. In the context, breast cancer is a non-communicable disease that cause the death of cause this every year, each year. The early detection of breast cancer in human in public health is a good idea in a developing country. Data on the physical characteristic of breast cancer can help to carry out diagnosis of cancer using machine learning. Eh, My screen has disappeared.
Your screen is visible, sir. Your screen is visible. Sir, you're not audible.
I don't see my screen has disappeared. I don't know why.
The screen is visible here.
Okay. It's okay now?
Yes, sir. Yes, sir. It's visible.
Okay. Okay. Data on the physical characteristic of the breast can aid in the diagnosis of cancer using machine learning algorithm. In the problem statement, how can the morphological characteristic of breast reduce perimeter, area, compactness, smoothness be used by machine learning algorithms to predict the risk of developing breast cancer? The general objective of PREPA is to build a machine learning model for diagnosing breast cancer in a hospital setting. Concerning the modeling of risk variable, we have used 5 variables to collect physical data on the breast cancer. We have the radius of the breast imaging texture, the breast perimeter, the breast surface area, and the breast smoothness. Here we see a shape of the breast, n'est-ce pas, showing the radius from the radius 1 to the radius 20. We use that radius to compute the average of the radius average of the breast. Concerning clinical interpretation of features of the breast, average radius measure the distance from the center to the boundary of the breast lesion. Smaller values often correlate with lower risk. Average perimeter represent the total boundary length of the lesion. More irregular perimeter may indicate higher risk. Average area, total surface area of the lesion, larger areas may be associated with increased risk. Average texture, measure tissue homogeneity, and pattern variation. More heterogeneous texture may suggest higher risk. Average smoothness, quantify boundary regularity, and contour smoothness, rarer boundary often correlate with higher malignity. Concerning the data scaling, we have to replace each column value x in the data by set by x1. Concerning the standardization, we have to replace x1 by x minus mu divided by sigma, where mu is the mean and sigma is the standard deviation of X. The machine learning model, we have used 3 machine learning models: the super vector machine model, the decision tree model, and the random forest model. Concernant the experiment were carried out, n'est-ce pas, using 568 patients. The data set has the following variable: mean radius, mean texture, mean perimeters, mean area, mean smoothness, and diagnostic. A value of 1 means that the patient is at risk of developing breast cancer, and a value of 0 means that the patient is not at the risk of developing breast cancer. The data are divided into 2 parts: a training part, 20%, 80%, and a test part, 20%. Data are import using the Python library pandas and load into data frame and X and Y. The data were normalized and to the same scale. The super vector machine, decision tree, and random forest algorithm were used for classification. The result of the random forest algorithm shows a precision of 97% with a record of 94% and a F1 score of 96% in predicting high breast cancer risk. The result of 10 indicate the model excellent ability to correctly predict cancer risk while limiting false alarm. The good performance of the model using the random forest algorithm could be useful as a field-level medical support for cancer. We also built an human interface prediction. It helps us to enter data that will help to the prediction. Now we are choosing the random forest algorithm to build the human-machine interface because random forest algorithm has a better F1 score. Here we present the data. You see here the first line and the last line of the data and the diagnostic column. This data set helps to learn the to the learning. We see here the result. We see here the result presenting 10 patients, the test result for 10 patients based on prediction probability. And you see that in the first line, the prediction value is 1 to say that the patient is at the risk of developing a cancer. And you also it is also be possible to have the value of the probability. We also observe that 2 patients may have the same risk of developing breast cancer, but with different probability. But have a look on the patient, a patient 9 and a patient 10. You see that they have a different probability. They have different probability. They have different probability. The prediction score is 1, but they have different probability. It can say that in the treatment they can take different treatment. In the performance for the performance of the machine learning algorithm, classification, we see here a classification report with super vector algorithm, the classification report with decision tree algorithm, the classification report with random forest algorithm. And we see here that random forest algorithm has a best precision as best F1 score. We also compute the accuracy of three machine learning algorithms for predicting cancer. We also see here that the random forest algorithm had the best accuracy. It is why we choose random forest algorithm for all our prediction. In conclusion, breast cancer remains a global public health concern due to the high number of deaths it causes each year in every country. Data collected from several patients has been used to build three machine learning models, super vector machine, decision tree, random forest, capable of predicting the risk of breast cancer. The best prediction performance was achieved by the random forest algorithm. The result in terms of accuracy are significantly better than those observed by other research who also use the random forest algorithm. The machine learning model and the application that we build could help government detect the breast cancer the early stage and plan treatment strategy. Thank you.
Thank you so much, sir.
Thank you.
Do we have any question from session chair?
Okay, so my question is related to the highest accuracy is given by the one particular random forest. So can you tell us about the why it is giving the better accuracy than the SVM?
You say that I don't understand very well your question.
Why random forest is giving the better performance than SVM?
Bon, I don't know how to explain, but when I run the simulation and I observe the result of the accuracy, I see that the better result, accuracy better result come from the random forest algorithm. And I also try to see the other work coming from the other researcher, and I see that the performance, the random, the accuracy of the accuracy of our random forest simulation is better.
Okay, thank you.
Thank you so much, sir. So with that, we'll move towards our next presentation. Our next presenter is Sergey Kubunsky, and the paper title is A Smart Fitness Assistant for Personalized Workout and Diet Recommendation Using Machine Learning and Psychological Feature Engineering. Sir, you may start your presentation.
Okay, hello. Let me share my screen. Just to confirm, can you see my screen?
Yes, sir, your screen is visible.
Okay, so good afternoon, everyone. My name is Sergey Kubinsky, and today I'm pleased to present our work entitled A Smart Fitness Assistant for Personalized Workout and Diet Recommendations using Machine Learning and Physiological Feature Engineering. So the research was conducted at the University of Plovdiv by Hilendarski, together with my co-author, Professor Emil Hadjikoles. Our main goal is to investigate whether those derived features can improve the machine learning models for personalized, as I said, diet and exercise recommendations. Okay, let me begin with the motivation behind this research. So personalized fitness applications have become increasingly popular because users expect recommendations that match their individual characteristics and fitness goals. However, most existing systems rely mainly on demographic and anthropometric features, such as age, gender, height, weight, and body mass index. And for this reason, we investigated whether adding physiologically derived features can improve the recommendation quality. Specifically, as you can see from the workflow diagram, we introduced basal metabolic rate, total daily energy expenditure, activity factor, and target calories as additional input features. And our objective was to evaluate their impact on the predictive performance of different machine learning models. Okay, the methodology of our article consists of four main stages of our research, sorry. First, we have dataset preprocessing, where we prepare the data for the machine learning models. Then we generate the additional physiological features using established nutritional equations. The next step is to train and evaluate several machine learning models, as you can see, decision tree classifier, random forest classifier, and multilayer perceptron. And finally, the best performing model is integrated into a prototype application that generates personalized workout and diet recommendations as well. Okay, about the dataset. For this research, we use the publicly available gym members exercise and dataset from Kaggle. Here you can see the main characteristic of the dataset. After pre-processing, the final dataset contained more than 14,400 samples. The dataset includes demographic information, health indicators, fitness goal, exercise preferences, and as well predefined diet and exercise recommendations. And also you can again see the workflow of the dataset preprocessing and yes, everything related to the dataset. These diet and exercise recommendations are used as the two prediction targets in our machine learning models. And before training, categorical variables were converted into numerical values, while incomplete records and irrelevant attributes such as ID, for example, were totally removed from the dataset.
Okay, sorry to interrupt, but I can't see your presentation because it's showing only first slide. Can you? Yeah.
That's strange. Okay, let me share my screen again. So, can you now?
Yeah. It's
Okay, I think I shouldn't press the present button. Can you see how I'm going through the slides? Should I continue?
yeah.
Yes, sir.
Okay. So yeah, the final point was about the dataset and the preprocessing. We can continue with the feature engineering. So the main contribution of this work is the physiological feature engineering process. Instead of relying only on the original dataset, we generated four, as I said, additional physiological features. The first one is the activity factor, which is based on training type and fitness goal. The second one is the basal metabolic rate, which is calculated using the Mifflin-St. Jeor equation. The total daily energy expenditure, which is computed from basal metabolic rate multiplied by activity factor, followed by target calories, which were adjusted according to the user's fitness goal. An important advantage of this feature is that they do not require additional medical examinations or wearable devices. They can be calculated directly from information that users already provide when creating a fitness profile. And this makes the proposed approach practical and easy to integrate into this or into existing fitness applications while still enriching the information available to the machine learning models as well. And yeah, our hypothesis was that those features would allow the model to better distinguish between users with different nutritional and training requirements as well. Okay, we evaluated 3 representative machine learning models. The first one is decision tree, which represents interpretable, tree-based, and fast-to-train model. The second one is multi-layer perceptron, which represents the neural network-based learning, and it can find more complex relationships between raw values in the dataset. And finally, random forest model, which represents an ensemble learning model and can provide greater robustness against overfitting. Several additional algorithms were tested during the preliminary experiments as well, but their performance was lower, so they were excluded from the final comparison. And the models were evaluated using the following metrics: accuracy, precision, recall, and F1 score. Okay, let's talk about the experimental design. The dataset was divided into training and testing subsets using 80% for train and 20% for test, which is most widely recognizable split as well. As I said, here are the evaluation metrics, and we evaluated 2 prediction strategies. The first strategy trains separate models for diet and exercise recommendations, and the second one predicts both diet and exercise recommendation using a multi-output model. This allowed us to determine whether solving the 2 tasks independently or jointly produces better recommendational performance. And now let's look at the experimental results. For diet recommendation, the additional physiological features clearly improved model performance. Random forest achieved the best overall results, reaching 94.22% accuracy with an F1 score of 90.44%. Decision tree also demonstrate considerable improvement after feature engineering, but in contrast, multi-layer perceptron showed only relatively small change, as you can see. One important observation is that the improvement was most noticeable for the tree-based models. And this suggests that random forest and decision tree were able to exploit the additional physiological features more effectively than the neural network-based models. Overall, these findings indicate that incorporating domain knowledge through physiological feature engineering can improve the recommendation quality without increasing the complexity of the machine learning models, and this was one of our main findings of our study. As you can see, the accuracy for random forest is improved with around almost 4%, and the F-score is improved with almost 12% for when adding the additional features for the models. Okay, let's now look the exercise recommendation model results. Random forest again produced the strongest results with an accuracy of 99.72%. However, unlike the diet recommendation task, the additional physiological features produced only
Sorry to
marginal
interrupt.
improvements.
Sorry to interrupt,
Yeah,
sir. It is a gentle reminder that you have only 1 minute left to conclude your presentation.
yeah, sure, thank you. Variables such as fitness goal, activity level, body mass index, and training preference already provide strong predictive information, and that's the reason why the results hasn't changed that much. Therefore, physiological feature has much greater impact on diet recommendation than on exercise recommendation. Yes, you can see the results. They're all bigger, but That's because the dataset contains so good information, and the exercise recommendation can be found really easy from every of the models. We also compared independent with the multi-output prediction model. Although the multi-output approach achieved good performance, they consistently perform slightly worse than the independently trained models. This may be because diet and exercise recommendation represents related but different prediction problems, and when separate models are trained, each model can focus on optimizing a single objective instead of bouncing between two different objects. And based on this finding, we select independent models for our application. To demonstrate the practical applicability as well, we developed a prototype called Smart Fitness Assistant. Users can enter their personal information, calculate physiological features, and receive personalized workout and diet recommendation. This application also supports user authentication and progress tracking. Based on our experimental results, Random Forest was selected as the recommendation engine of the application. Yes. So to conclude, this study demonstrates that physiologically derived features can improve machine learning performance for personalized fitness recommendation system. The improvement is particularly significant for diet recommendation. Among all evaluated algorithms, Random Forest achieved the highest performance. We also found that independent models works better than a joint model, multi-output model. And yeah, in future, we want to evaluate the system on larger and more diverse data set to integrate wearable sensor data for real-time physiological monitoring, such as smartwatches, for example, to explore deep learning architectures for personalized recommendations, and hopefully to develop a mobile version and conduct real-world user studies. As you can see, the key takeaway from our research: physiological feature engineering is an effective approach for improving machine learning-based personalized workout and diet recommendations. Thank you very much for your attention, and if you have any questions, I will be happy to answer them as well.
Okay, so as per your experiment, again, the random forest is best performing model for diet recommendation. So as
Yes.
compared as other model, so why it is better? Is there any novelty or have you done something in existing algorithms so we can say random forest is better than SVM and other?
Okay, so yeah, that's a valid and very good question. Maybe the dataset contains different types of features and potentially complex relationships between them. And random forest model can found these interactions effectively by combining multiple decision trees in one model as well. I think it can capture nonlinear relationships between, as I said, the demographic, the anthropometric, the physiological, and lifestyle features such as health indicators and so on. And it is relatively too robust to overfitting, and maybe that may be the reason why Random Forest achieved the best performance among all other models.
So all these are the existing models. So from your side, what you contribute?
Yeah, I contribute with that the physiological features that we added during the testing improves the machine learning results and evaluation metrics and prediction performance as well.
Okay. Okay, thank you.
Thank you so
Thank
much,
you.
sir. So with that, we'll move on to our next presentation. Our next presenter is Madhulika Gachila, and the paper title is Architecting Future-Ready Digital HR Platforms Using Workday Cloud Services and API-Driven Ecosystem. Ma'am, you can start your presentation.
Thank you. Am I audible?
Yes, ma'am, you're audible.
Thank you. I'm sharing my screen. Is the screen visible?
Yes, ma'am, it's visible.
Okay. Good morning, good afternoon, everyone. I'm Madhulika Gajala. Today, I will present my research titled Architecting Future-Ready Digital HR Platforms Using Workday, Cloud Services, and API-Driven Ecosystems. So organizations today depend on multiple cloud applications to manage HR functions such as recruitment, payroll, talent management, and employee engagement. Although these systems are powerful, they often operate in isolation, making data synchronization, interoperability, and intelligent decision making difficult. So to address these challenges, we propose AFDHRP framework, which combines cloud integration, API-driven interoperability, workforce intelligence, and adaptive optimization into a single architecture for next generation digital HR platforms. Over the next few minutes, I will explain the motivation, architecture, algorithms, experimental results, limitations, and also the future direction of this work. Okay, let's first understand the key challenges organizations today face with the digital HR platforms. Okay. Okay, can you see the problem slide, the next slide? Just want to ensure that you could see the problem statements slide.
Yes, ma'am,
Okay.
it's visible.
Sure. Thank you. Okay. The first, workforce data is fragmented across many applications today, Workday, cloud services, and third-party applications. And second, integrating heterogeneous systems remains challenging because they use different technologies and formats. And the third, it delays in synchronization, reduce the availability of real-time information. And finally, organizations require scalable platforms that can generate intelligent workforce insights. These challenges motivated us to design an architecture that improves integration, synchronization, and decision support. Let's briefly review the related work that's already to this work. So the work on cloud edge computing, workflow scheduling, and process orchestration. So these studies significantly improve cloud infrastructure performance, but do not directly address enterprise HR platforms or workforce intelligence. This gap inspired to develop a framework specifically focused on Workday-based digital HR ecosystems. And here is the existing literature provides valuable insights, but we need an appropriate benchmark models to evaluate our framework. There are two comparable approaches we selected for comparison. So for comparison, we compared a framework with two enterprise cloud optimization approaches. One is the Deep Hill, which is a deep learning-based ERP optimization model. While they're not HR-specific platforms, they provide usual enterprise baseline for evaluating interoperability and optimization performance. Okay, and so this is, while identified the research gap and comparison baselines, I would like to introduce the contribution of this paper, which is the AFDHRP architecture. So the proposed AF-DHRP framework consists of 4 layers. The cloud service integration layer connects Workday and cloud services. The API-oriented interoperability engine enables secure communication between systems. And the workforce intelligence management module transforms synchronized HR data into meaningful insights. Finally, the adaptive digital HR optimization unit applies predictive intelligence to support HR decisions. Together, these modules create a scalable and intelligent HR ecosystem. So the architecture is powered by 2 complementary algorithms. I'll begin with the first algorithm, which focus on the data synchronization and interoperability. So a first algorithm is CHDSI, focuses on synchronization and interoperability. It evaluates connectivity, API accessibility, synchronization rate, and data consistency before calculating integration intelligence and synchronization confidence. The objective is to ensure that reliable and consistent HR data is available before performing analytics. So once reliable and synchronized HR data has been established, the next step is to extract meaningful intelligence. This is where our second algorithm comes into the play. So AWIHO analyzes workforce productivity, engagement, retention, learning adaptability, platform scalability, and also the API performance. These metrics are combined to generate the cloud ecosystem efficiency score, enabling better workforce planning and decision support. Now that we have discussed both algorithms individually, let's see how they work together in the complete end-to-end workflow. Okay. This slide summarizes the complete workflow. Data from Workday and connected cloud systems is synchronized and validated through CHDSI. Okay. The validated repository is then analyzed using AWIHO to generate workforce intelligence and support HR decision making. So separating data validation from analytics improves the reliability and accuracy. So after designing the framework, the next question is whether it performs better than existing approach. So let's look at the experimental results. We evaluated the framework using datasets ranging from 1,000 to 8,000 records. Across different data sizes, AFDHRP consistently achieved higher interoperability, efficiency, and workforce intelligence compared with the benchmark models, demonstrating the effectiveness of the proposed architecture. Beyond the comparing performance, it's also important to verify the consistency and reliability of our results. This brings us to the statistical validation. So to validate consistency, we conducted 10 repeated experimental runs. The framework achieved approximately 99% performance across the reported metrics with low standard deviation and statistically significant p-values. So these results indicate stable and consistent performance within the experimental environment. Although the results are encouraging, so every research study has its own limitations. So I would like to briefly discuss those along with the opportunities for future work. So this work uses a synthetic HR dataset and compares against enterprise cloud optimization systems rather than the dedicated HR platforms. Future work includes benchmarking against SAP SuccessFactors and Oracle HCM Cloud while incorporating generative AI, LLMs, and blockchain. To conclude, I would like to summarize the key contributions and findings of this research. AFDHRP provides a unified architecture that integrates Workday, cloud services, APIs, and workforce intelligence into a scalable digital HR platform. The results demonstrate improvements in integrity, interoperability, synchronization, reliability, and platform effectiveness. Thank you so much for your time and attention. Please do let me know if there are any questions. I would be happy to answer.
Okay, so is there any similar kind of architecture is available?
We do not have a similar kind of architecture. I have proposed two algorithms. So there are models involving one of it, but here we would like to bring them together to achieve the interoperability and the accuracy.
Okay, so when you are saying when we integrating the different things on one platform, so which thing you can achieve, or you can say this is the new thing I found when I integrate different things on a one platform.
Yeah, so the core of it is we separate reliability and validation with the intelligence. So we want to validate first, we want to be reliable on data before we work on the intelligence of the intelligent decisions. So this is a core area of this research to improve the efficiency and also the interoperability.
Okay, thank you.
Thank you, sir.
Thank you so much, sir. Thank you so much, ma'am. With that, we'll move on to our next presentation. Our next presenter is Rose Hernandez Corteza. Paper title is Digital Transformation Model for the Insurance and Certification of Academic Documents using Blockchain and the Interplanetary File System, an institutional case study. Sir, you may start your presentation.
Can you see my screen?
Yes, sir, your screen is visible.
Thank you. My name is Jose Hernandez Cortázar. Today I will present a digital transformation model for the usage and certification of academic documents using blockchain and APF. This was an institutional case study. Yes. Let me start with the numbers of our institution. Every year, we use around 6,400 credentials. In a peak year, almost 11,000. Today, the student receives a PDF file and has a QR code and digital signature. But there is no one problem. Only the institution can verify the document. QR code points back to our one server, so the trust depends completely on use. If employer in another country receives the document, he cannot verify it by himself. He must contact us and wait. We review the literature and we found two gaps. First, most blockchain credential systems are isolated technical implementation, the with technology, but they don't know study the organizational process where that technology must operate. Second, APF is rarely combined with blockchain in academic certification, even other great advantages. So our objective is to design a digital model, transformation model, and system architecture that integrates blockchain and APFs to improve integrity, traceability, and verifiability. We made four contributions. The most important was the four, a multi-layer verification workflow that other institutions can replace. Our methodology is a descriptive and explanatory case study with source triangulation. This was not only a document review. We did field work, we observed the certification process directly, and we interviewed the system administrator on the institution. The study had 4 stages. Stage 1, first, organization analysis. We mapped the process with data flow diagrams. Second, we designed a hybrid architecture with 4 layers. 3, we developed the smart contract in Solidity. And 4, we evaluated the prototype with stress tests. The important idea here is that the process mapping became the requiring specification for the smart contract. The technology followed the process, not the opposite. This is traditional process as we map it for sequential steps. The student makes a request, the administrative staff validates, the central server generates the document, and the document is stored in a local database. From the map, identified 2 vulnerabilities. The first one is a single point of failure. Everything depends on one server and one database. The second is the risk, the duplication, or alteration, no external traceability. This our proposed architecture. It has 4 layers. Layer 1, the user layer, the web interface for the student and administrative staff. Layer 2, the business logic, Python and Solidity, plus a local database that keeps only metadata. Layer 3, the centralized storage, the PDF document is stored in APF of chain. Layer 4, the mutable registry, a smart contract on the Sepulia network on chain. The key design decision is on the right. We call it trust decoupling. The document itself never goes to the blockchain. Only 2 things one chain, the hash of the PDF and the APF content identifier. So the blockchain does not carry the document, it carries the proof that the document has not changed. This word keys the cost log, and this is one mistake the system is scalable. The smart contract is not only a storage place, it's a governance engine on the system. It is host 3 models. First, while it's managing, we implemented role-based access control. Only wallet addresses authorized by the institution can issue and document. Any other address is read automatically. Second, the certificate registry. This function links the hash of the PDF with the APF identifier. If somebody changes on single byte of the document, the hash changes and the verification fails. Third, this one is important, the verification model. Many blockchain proposals are purely static, once granted, forever valid. But institutions make mistakes, so we include a revoke function. The institution can invalidate a document, and any third party sees that change immediately. Now, how does the complete circle work? Step 1. The student is validated in institutional database, and the system check in a credential was already issued. This block duplication before the document exists. Step 2. The PDF is generated with each QR code, and we compute the hash of the file. Step 3. The file goes to APF, and we receive the content identifier. Step 4. The hash and the identifier are graded on chain by a smart contract. And here is the main contribution. Because these three sources can be cross-checked, any third party, an employer, another university, a mission, can confirm the authenticity of the document without asking you, without entering of your system, without waiting for your staff. The measures, our measures, results, the complete issuance cycle hashing, APF unload, and on-chain registration, consumed an average on the 327,000 gas units, and the backend logic executing 70,945 microseconds, about 18 milliseconds. I want to be precise about the figure. This is the execution time on our backend service logic. It's not the block confirmation time on the work. Confirmation depends on the Ethereum network and is dependent of our designs. What is Ethereum in the bar below? Because the PDF stays on-chain, the on-chain payload is only a hash and identifier. So the gas costs stay predictable and institutional scale, and the backend is not the bottleneck. I want to be clear about we did not claim. First, our metrics come from the Sepolia test network and from individual transactions. We did not test recurring multi-user workloads. Production behavior might be different. Second, one institution. A single case study limits organizational generation. Third, long-term persist in APF is not automatic. It requires planning strategies and clear governance of the network. Our next step are multi-user load testing and cost analysis on our production network can replace in other institutions. To conclude, the mesh is the word is sample. The technology follows the process and not the opposite. We deliver three things. One, a replicable model that combines blockchain, APF, and a smart contract with a qualitative analysis of the institution. Two, verification that does not need use. The institution stops being a mandatory intermediary. And three, duplication is prevented before the document is even generated. For public higher education institutions, this is a practical framework, not only a prototype. Thank you. Question or welcome.
Okay, so what is the novel thing? Your contribution.
Excuse me. Repeat question, please.
Okay, what is the contribution from your side? New thing.
Contribution. Contribution. This is contribution is yeah, excuse me. Or contribution is can you secure and traceability, security, and, is- and, and prototype, more or less.
Okay. Okay, thank you.
Thank
Thank you so much, sir. With that, we'll move on to our next presentation. Our next presenter is the Shama Nuruddin. The paper title is Intrusion Detection System Based Lightweight Ensemble Machine Learning for the Enhancement of IoT Security Against the Cyber Attacks. You may start your presentation, ma'am.
Thank you very much. You can see the presentation?
Yes, your screen is visible.
Our subject instruction detection system based lightweight ensemble machine learning for the enhancement of Internet of Things security against cyber attacks. The researcher Shemawa Al-Nuruddin, Nusra Abdul Hamad, and Nahda Naji Kadam. What's the meaning of AIoT? It is two words, artificial intelligence of things and artificial intelligence and Internet of Things. This paper aimed to build an intrusion detection system using the proper sensible machine learning, DTXGRF, and examined it against the existing machine learning DTXG boots, RLR, KNN, RF, NB, and CATBoots for D data sets. CIC, Internet of Things D 2023, and Internet of Things D20 in terms of precision, accuracy, recall, F1 score, and confusing matrix. By combining the predication of decision tree, XG boots, and random forest, the goal is to create a more robust and accurate predication system by leveraging the strength of different individual models to improve Internet of Things performance against cyber attacks. This table shows the related work related to our research. What's the meaning of intrusion detection system? Protect Internet of Things by analyzing network data to detect threats and alter administrators. Adaptive intrusion detection system using artificial intelligence and subset machine learning and deep learning to recognize data patterns and forecast multi-layer attacks. Research method. The ensemble model combine multiple algorithms to outperform signal models. Algorithms are DT, which is mean decision tree, and XGBoost, which is mean etc. gradient boosting, and KNN, RL, catboots, and NB, which mean never spice. Tested on dataset SIS. We remember it's Internet of Things 2023 and Internet of Things D20 dataset across binary, multi-class, and Getroy classification is evaluated miscellaneous and beginning with traffic using accuracy precision. Recall F1 score and support. This block diagram shows the overall system, which we explained later. Research method. According to this block diagram, we can explain the research method. The system step of the simple and machine learning models are pre-processing pipeline to ensure concentrated clean data, to remove incomplete rows, to avoid errors, and verification to ensure that the data is structured and comprehensive. The dataset is divided in training and testing subset, resulting in 20% of the data available for testing and 80% for training. Specify the foundational model, DT, executes, and RF. Create and configure the voting classifier using the list of base model. Set up the ensemble model to work. During the training, it is establish a checkpoint to save the model with the highest validation accuracy. The evaluation is performed by loading the base store model. Makes a prediction about the test set class probabilities. Generate measure for the model's assessment and display the model precision, recall accuracy, and F1 score on the test set of each machine learning model over all classes. Research method. The goal is to create more robust and accurate prediction system by leveraging the strength of different individual models. The successful models is examined utilizing Python 30.12 and trained on the machine configured with an Intel R Core TMI 78569U CPU, 2.8 GHz and 16 GB RAM. The feature selection and classification procedure were executed utilizing the scikit-learn package. The process model is evaluated against many conventional machine learning models using the datasets. This data set based on several assessment measures like accuracy, precision, recall, F1 score, and the area required. You see, these evaluation metrics are determined from the true negative, true positive, false negative, and false positive. What meaning by the dataset? The dataset has been created by compiling data from many sources dataset based on Internet of Things and critical for evaluating Internet of Things security, and several researchers employ them for their studies. Three datasets are available in the current research for evaluating the performance of intrusion detection system CICD 20 and 23 and Internet of Things TD 20. Evaluation metrics. There are more than evaluation metrics, such as accuracy, which is equal number of correct predication over total number of predication, precision, which is mean calculation, the ratio of the correctly accepted position outcome to the total predicated positive, and recall, which equal TB over TB plus FN, and F1 score combines static of accuracy of precision and recall ranging from 0 to 1, defining as 2 multiply recall multiply precision over recall plus precision. Result and description. The machine learning consists of the following primary steps. Data acquisition. This primary phase comprises the gathering of training data. Data representation. This phase encompasses the cleaning feature selection using standard scalar normalizing, data splitting, and alternating the training data in order to make it appropriate to the pre-processed by the machine learning model. Model selection and the training. In this phase, suitable machine learning model are determined. Then the model is trained on the training data to identify pattern and correlations in the data. Model analysis. After training, the model uses a specific data set test data extracted from the training set to analyzing. Result and discussion. The accuracy, precision, recall, and F1 score has been evaluated for the IDS utilizing the initial model for CIC IoT 2023 datasets table to show the result performance metrics for this dataset. For more than algorithm, such as this is machine learning model, and we find accuracy, precision, recall, upon score, and accuracy. For the another set of data, Internet of Things D20 data set, we find this result for accuracy, precision, recall, F1 score, and accuracy. This result and discussion for machine learning accuracy and subcategory classification for dataset which this type shown in this table. And for another dataset, Internet of Things D20, the results shown in this table. The data new algorithm DTXGRF is enamel IDS extract sequence feature using one-dimension convolution layers and combine predication to reduce variance evaluated for this set database and this Internet of Things D20 dataset. Its output it outperformed a conventional machine learning model with over 99 accuracy on a major attacks proving reliable and generalizable for Internet of Things security. Conclusion, the new algorithm assembled the IDS was evaluated against DTXG boots, LR, KNN, NB, and CAT boots using two datasets, this and this dataset, and they use 2% 18 to 20 split measured by accuracy, precision, recall, F1 score, and R of security. It outperformed the baseline model, achieving multi-class accuracy of 95.004% for CIC, Internet of Things 2023, and 99.99970% for Internet of Things D20. It harnessed real-world protection against punishing run somewhere and MITM attacked with viewer false alarms. However, accuracy was lower for ransomware and uploading attacks due to the class imbalanced data separation and feature overlap. A future work will add a transformer of RNN for real-time streaming data. Thank you very much.
Okay, so your proposed model is producing almost 99 means 100% accuracy. So can you elaborate why it is producing almost 100% accuracy?
Wait, please.
Okay, so your proposed model is giving highest accuracy up to 99%. So why it is giving such accuracy? It's almost 100%. What is the new thing in proposed model?
I'm sorry, sir, but I can't hear.
Okay, novelty of proposed system.
What?
Novelty. New thing from your side. What you added? New thing from your side.
We added transformer for the future. Transform for the future.
Okay, ma'am. Thank you.
Thank you, thank you.
Thank you, sir. Thank you, ma'am. With that,
Thank
we'll move towards our next presentation. Our next presenter is Manuela Moreno Arciala. The paper title is Design of a Productivity Capacity Index for Software Teams Using a Multidimensional Socio-Technical Model. You may start your presentation, ma'am. Ma'am, are you there? I'll do the final call for Manuela Moreno Arcila. Ma'am, are you there in the meeting? Please switch on your. I think we are done with today's presentation. As we come to the end of this technical session, I would like to sincerely thank all our authors for their excellent presentation and valuable contributions. I also extend my heartfelt gratitude to all the participants for being a part of this international conference. I hope today's session has been informative, engaging, and on behalf of the entire team, we thank you for your continued support during the 10th edition of World S4 2026, as well as throughout the previous 9 editions of the conference. We look forward to welcoming you again to the 11th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The conference publication will be available within 7 to 8 months. We kindly with the World S4 2026 team throughout the publication process. I would also like to express my sincere appreciation to our session chair, Dr. Deepak Mane sir, for successfully chairing this technical session. I would like to request Deepak Mane sir to kindly share their remarks on session about the session.
Okay, all participants has presented their work very well, and also I'm very much thankful to conference organizing committee for giving me to work as a session chair for your conference. Thank you, ma'am.
Thank you so much, sir. On behalf of Team World SO4 2026 Global Knowledge Research Foundation and our partners, please accept this certificate as a token of our appreciation, valuable support and contribution. Thank you once again for your valuable presence and participation. This concludes our session. Before we end, I kindly request everyone to switch on their cameras for a quick group snapshot of our virtual conference. Just a few minutes. Anyone is sharing their screen, please stop sharing the screen. Thank you so much, everyone. Have a nice day. You may leave the meeting.
Thank you and have a nice day as well.